This session I'm super excited about. First of all, because of the topic, and second of all, not in this order. Let me say, first of all, because of the amazing instructor. Second of all, because it's on a topic I really care about. You can think of this session as like a mini introduction to computer science, which is what I studied. I love to program, I told you all. Salem has put in an incredible amount of work into trying to consolidate all of computer science into a little deck. And it's going to have a really cool activity that I won't tell you, so you can be surprised. But I think this is a really good representation of what you would see in a course in computer science. And I think Salem has done really impressive work in consolidating a lot of material. So Salem is the Director of Service Delivery at Oslo Technologies. We're very lucky to have someone like him. He's been here for 6 years. Oslo has some of the biggest companies in the world as its customers. Salem himself is in charge of 120 different engineers here at Oslo. So if there's somebody who knows a lot about technology in Palestine, it's him. Before coming to Oslo, he was working in the United States for 18 years at a bunch of different companies, among which was Motorola. He has a master's degree in telecom management and also an engineering degree. So he's super smart, super experienced, and like all the other instructors, has volunteered for Start Me Up, put a lot of work, as I said, into this session. So we're very lucky to welcome him in teaching Introduction to Business Technology. Thank you very much, Salem.
Thank you for allowing me to do this and share knowledge. Hopefully I'll make this session not dry. Usually computer science is dry a little bit. Everybody's okay with English? I'll probably mix here and there in English, but I don't know, my tongue is the hardware switches. Close the door and hit the lights. Three important things. Refreshments are there, help yourself. Bathrooms are just outside the door, to the left, to the cowboy doors. So, please shut off your fingers and your notes. From my session is to provide you a technical overview of computer science by Taylor said. And I'm going to try to stuff a lot of material. Some of you come from a technical background and you have this background, but I'm going to try to put more of a managerial spin on it, so you have introductory knowledge of certain things that if you intend to venture or open a business or a startup, whether it's technology oriented or even any kind of startup these days, you need and you will be exposed or use technology in some form or shape. But mainly I think it will be most beneficial for those of you who are planning to build web applications, websites or software as part of your core business. I will try to give you some background on software development, the processes, different processes that are being used and that are most effective in the industry these days. And then we will cover throughout the session some technical jargon, buzzwords, things like that that you might hear here and there, and at least you'll be aware of what they mean. Then we'll try to expose you to an activity and to some discussions that will hopefully expose you to think more like a developer. Okay, and the reason you need to learn how to think like a developer, because you'll be able to manage them better and communicate what you need, your business needs, to them better if you speak their lingo. And if you ever try to explain what you want to a developer, you will understand what I mean. It's frustrating. So hopefully we bring the viewpoints closer together. What is programming and why do you care? Of put in its simplest form, programming is a set of instructions, okay, used to solve a problem. And the most important part of the whole programming world is solving that problem. Okay, we care about the instructions, we care about getting there, but if it doesn't solve the problem, it has a bunch of fancy things, it's useless. So foremost, and the most important thing in building software is making sure that you understand the problem. It could be a customer's problem, it could be your problem, selling a product. Selling a product is a problem. How am I going to sell my product or mass sell my product across the world? I need to open a website, web application, it needs to have accept Visa, MasterCard, whatever. All of these are problems and issues that you have. The big problem is you want to sell something. The smaller problems chopped up into, okay, I need to take different kinds of credit card. In Palestine, they take credit cards, I need to find a form of payment. All of these are types of problems that you need to solve. Mainly in trying to identify the problem, you need to understand your audience, your stakeholders. Stakeholders are people that usually in our industry, they're people that pay for the software to solve a particular problem. They might be a manager of a department, of an HR department that wants to organize their work and save time and therefore save money. Or they might be a manufacturer that wants to create greater exposure by creating a web commerce, e-commerce site to sell their products. So you need to understand those stakeholders, talk to them, and understand what they really want. So developers usually, I smile because developers usually don't talk a lot, but to be very effective, you must be able to communicate, listen. So usually good developers are the ones that listen more than talk. Okay? Because you're trying to listen to your customer, you're trying to understand exactly the problems that you're going to go later on on some computer and try to solve. Always when trying to solve a problem, you have to figure out if it can be dissected or split up into smaller problems. The basic concept of divide and conquer. So a lot of problems seem big and great, but if you split them down into smaller units, each smaller problem can be solved easier, in an easier way. Also representing a problem graphically, they say a picture is worth 1,000 words, and it's usually worth 1,000 words. So if you can draw things out, and this is how we communicate usually as analysts to developers, we try to draw things out, we try to draw interfaces, but we will later look at some examples. Then after actually understanding the problem thoroughly, you have to plan the solution. Not just jump into coding. So, first of all, when we try to plan the solutions, we try to dissect things into, have I seen something like it before? Okay, am I familiar with something like it before? Or I have no clue about it. So, if I've seen something like it before, chances are if I can dissect the problem to a smaller piece that I have seen something like it before, I can use that same solution on that little portion of the problem. And if I recognize it, I've seen somebody else or I read about it, I can probably approach a solution. If I don't know anything about it, then I have to do a lot of research. So that's a big unknown. So knowing the unknowns in your project while planning the solution is very important. Then you would have to carry out the plan. Most importantly, you have to plan for a solution, look for a solution, and then in essence test it or hypothesize whether it's going to work or not. Because sometimes you dissect your problem into little pieces, and you solve all the little pieces, but the little solutions don't go together very well. So you need to test that. You need to see if it works out and try to change these solutions. And then the most important thing, I think, in software development in general, in IT development, is examining the results. So once you propose a solution, you try it out. Trying it out and testing is one of the most important things in my experience in IT implementation, software development, or even purchasing software. People don't recognize whether what they have solved the problem or not until they start playing with it. So try to get, the key thing is to try to get to that stage as soon as possible, as quickly as possible. Some of the software myths that, if you're from a technical background, you might have encountered them, and if you're not, you will encounter them because you will work with developers and they will talk and they will give, try to convince you of certain things. So I wanted to share 3 big issues with you. Myth number 1 is once we write the program and get it to run, our job is done. Okay? Problem is in software development companies, managers, inexperienced managers, they'll hurry and they'll rush developers to start writing code, to start writing the program. And that's one of the biggest problems is without defining the problem, without really planning the solution, thinking about it, examining the solution. Coding is the last thing, programming is the last thing that you want to do or approach. So don't let developers drag you into that, or even managers drag you into that, or even business users drag you into that. Sometimes we're nervous about starting, and we just want to see code. The biggest problem is actually programming something that nobody wants. It doesn't solve the problem. So this is a big myth, and the reality of the matter is the sooner you begin, the more problems you have and the longer it will take to get done. 60 to 80% of all efforts spent on software development are spent after the first delivery or after the customer gets the first version. So imagine all that time that's spent, you still need to put 60 to 80% on top of that to reach something that is useful for the customer. So don't rush into writing code, writing programs. Second myth that I wanted to share with you and this is what developers are famous for. I'll tell you, okay. Until I get the program running, I have no way of assessing its quality. Say, how good is it? How good is the solution? How good is the software? I don't know. I can't tell you until I test it. Until I'm done and it's running and I test it. And that's not true, because there are other ways and other methods to test your hypothesis, test your solution. So the reality is technical review and quality is enhanced by you actually testing and assessing your solutions before even coding the program. There are various ways that you can do that. For example, if we'll talk later a little bit about mockups and things like that. If you draw a user interface out, you can draw the user interface. And then you can invite a couple of users and ask them about the interface. Try to pretend and interact with the interface, although it's not the real interface. That will give you insight on how to really build the interface well. And a mock-up pen, and you can draw it out in probably 10-15 minutes, instead of spending months on something that you'll find out later doesn't work. Okay? So that's very important for building software products. I heard this myth a lot here in Palestine more than anywhere else, is that software engineering causes us to create a lot of documentations, a lot of paperwork, waste a lot of our time, and it's not necessary, and it slows us down. And that's a complete myth, okay? A lot of the software companies here, they start with, they start coding right away, they think they know what the solution is. And the reality is that software engineering leads to better quality, and better quality leads to better work and less rework. And therefore, your delivery times are going to be faster rather than slower. And you have to believe in this. You have to really believe in it, because you will find a million people around you that tell you, all of this software engineering crap is going to slow us down. And it's a waste of our time, and we're not really working on the product. And the fact of the matter, if you don't exercise good software engineering practices, your quality will be affected, and the final output will need to be reworked and reworked and reworked, and therefore you're going to be delayed. One example from my life, when I used to be a software developer, I was labeled as a slow programmer until I actually took some facts to my manager, showing him that when I program something, most of the time it doesn't need to be reworked. While when others submit their work quickly, there's a defect after defect after defect. And if you calculate all that time, it means that I'm not slow, I'm faster. And it took me about a year to convince my manager that it was faster. Anyways, I think it was persistence that led to success.
And does that documentation work against the small projects?
Documentation? Well, you have to be careful about documentation, because if you're really very, you don't need to document everything, because you're documenting things that are necessary. And rather, the best if you use, we'll talk later about frameworks and APIs and things like that. And if you use frameworks and you use standards, it saves you a lot of documentation, because standards are common languages. And common languages means that you have to say less for somebody else to understand the same thing. So that a lot of documentation can be avoided, but doesn't mean that no documentation is good. No documentation is horrible. Anyways, these are three very important myths that you will hear if you work with developers, work with IT people, you're buying software. Most of software usually is bought before it's actually developed. Anyways, then we move, I want to move to product development. Product development, if you're developing any product, you're always looking for an MVP, at least in the lean methodology for startups. And an MVP is finding the sweet spot between the minimum product that you need to build and the viable product that you need to build. Okay. Viable means what makes me money. Is it viable? Is it gonna, am I gonna survive if I spend a lot of time on this? And finding the cross between what is minimally acceptable to the users, so it has a good set of features to test user responses. So you can't go to market with an MVP that doesn't have enough user features, or doesn't have nearly as many user features as the primary competition that you're competing against in the market. So it's very important to find that sweet spot of features. And the key thing in product development is to get continuous and constant feedback from your potential market. And keep pivoting, keep learning, building, learning, and adjusting. Building, learning, and adjusting.
How can we apply this idea on the app development? I mean,
Applications?
yes. Because once you release the app on App Store, it's not easy to like to get feedback and update it accordingly.
You have to actually sit back, specifically App Store applications, you have to get the feedback before. You have to know the market segment and try to run around physically and find the people that your friends, family, fools, neighbors, people that you think are the representative of the market segment that you're after, and try to actually make them test it, make them go through it. Once you get things on the App Store, you can actually pivot and adjust, but you have to have at least a minimal viable product by that time.
Yeah, for a closed group.
Because it's a big process with the Apple to get something set up. We'll talk a little bit in a few slides more. We'll talk about some methodologies that you can use, specifically Agile or Scrum, that will help a lot in developing products as well. Typically, and this is the same with products, but every software product usually starts with a business need. They need to correct a defect, they need to take a legacy system and renew it, because we need a modern interface. People are sick of looking at the old interface, and it's generations change, people change, interfaces need to change, technology changed. They need to extend functions, and they need to create new products and services. And primarily, like I said before, the need emerges from solving a problem. If your system or solution or software does not solve a problem to the user, then nobody's going to use it. Now somebody will ask me, what about gaming? What problem does gaming solve?
Entertainment.
It solves boredom. But then, we can discuss that, but it's solving a problem. You're still solving some sort of a problem. You have to establish a culture and a mindset of software engineering if you want to create a successful, quality product. Okay? We are not famous for quality software in this region. I'm not speaking about Palestine, I'm speaking about the region. Okay? Because we think that the software engineering stuff is wasting time. And we don't believe. Some of us do, but it's very hard to push. I even have this problem in the US, managing the departments and managing the small teams. Because everybody wants money and they want it fast, and they don't want to think that they're wasting time. So you have to make them believe that software engineering best practices will lead to quality, and that will lead to reduced amounts of money. And if you can prove it, you will move ahead.
But you can find a lot of examples of companies or larger scale because they take software engineering to be very formal.
Very formal?
Or to extreme.
Yeah. It can go to extreme. Motorola, I worked for Motorola, and it went to an extreme. That software engineer, we had code reviews and formal code reviews and things like that. And that caused Motorola, what you're saying is absolutely true. So there is a balance, but not doing it is a problem. Doing too much of it is a problem. Motorola was almost, I think one of the problems that Motorola had is that they were always late to market with their products. Somebody beat them to the punch all the time. They had the best products, somebody beat them. I remember when they were manufacturing the Motorola Razr, the flip phone. I think it was one of the first flip phones. It was a great phone, okay, but they were late to market. Nokia, I don't know, I forgot which phone took the market over, because they just came out with a good phone a few months before. So what you said is absolutely true. So you have to balance. You have to, but not doing it at all is a problem. So make sure you keep things simple, stupid. Apply the KISS principle to software development. Don't overcomplicate things. Even if your developers will try to overcomplicate things. us developers, we do tend to want to and we like to complicate things. We do. I believe it. I've seen it in 120 people.
So doesn't that make things more complicated down the line if you want to edit or if you want to add
To keep things
features?
simple?
No, that makes it easier. But if you complicate things, then
Absolutely.
so then why would they want to keep making it complicated?
Because they like challenges. They want to be geeky about it. Yeah. You know, so if there's a way to do something simple, they want to impress you. Okay, as the business owner, as the manager, as the CEO, they want to impress you and do it a little bit more complicated. Although that little bit of complication takes them a lot of time, they might, sit throughout the night doing it. They'll still want to do it to impress you, but it's going to cost you more down the road because that's stuff you don't need. That's part of the bigger product that we're talking about, the green circle. That's a waste. Nobody's going to use it. There's a lot of things on my iPhone that a lot of people don't use, but somehow it got there because somebody thought it was cool. Okay, they could have done something, a different feature, instead of wasting time on that one that is more common. You have to, whether you're producing the software or your developers are producing the software, you have to instill this in them. People are going to consume what you produce. So if you consume crap, then that's what people are going to get. And that's not something that you want. And you have to be open to the future all the time. Like you said, it's very important to keep that vision of the bigger picture in the future. I see way too many companies, they get locked into a piece of software that they built. They kept saying, okay, this is all we need, this is all we need, we don't need anything else. And sometimes we advise them that, if you do it this way, in the future, if you have more users, then you can expand. No, we don't want that. It's either sometimes money or sometimes just stubbornness.
So I have a question. So would you say the most effective way of launching an app into the market or a product into the market would be by addressing specific services and then going towards that main vision, or do you think that it should be more focused towards the main vision, the initial vision that you have, like with all of the course?
You should never lose sight of the main vision, because the main vision is what gets you the whole big picture. Okay. However, you should be flexible enough to test your product with the users, because your vision, and you have to accept this, your vision might not be true or good for everybody else or the market. And after all, you're not after your vision, you're after making money. You're after selling a product, solving a problem. So if you think people's problem is they need to know grocery prices, so they go to the right supermarket, testing that might show you that that's not their problem, that's your problem only. And the mass problem is something else. And that might lead you to actually developing other products. And that might give you ideas for other products.
So what if it's a multifunctional? You're addressing more than one problem. How do you go about launching a specific service? Would you do it piece by piece, or would you do it as a whole?
Like I said, it's very important to do it piece by piece. If what you're trying to do is be lean about it. With startups, you should be lean about things because you're getting finance, you're getting, so you want to spend your budget and your money where it's most effective. So you want to find out where it's most effective. Where is the mass number of people in my market? Where's that spot? Who are they and what are they trying to solve? What are they willing to pay for? And that's what I want to attack first. Because if I hook them on that, then I can, wow them with other things that I can produce later. And always think of reuse and encourage your. I'm going to skip those two slides. Do they have access to these slides later on? Okay. Because these are things that you can probably read on your own, and I don't want to go over time. I want to make sure that I cover. This is the classic software development model, which is the waterfall. Okay, the waterfall is crap. This is a waterfall. What's at the end here?
Result.
Results? I'd say there's a bunch of turbulence here. There's a bunch of turbulent water, and this is how it is in software development. You know, you go through this waterfall, you gather requirements, you do system design and software, you implement, you do integration and testing, you give it to the customer, and you start the operation and maintenance, and all kinds of bugs come out and problems, and this is not what I wanted. This cycle may take anywhere from 6 months to a year, build something very small. And the client talks to you here in January, he gets it in June, July, and it's not what they wanted anymore. Life changed, the world changed, the market changed. Okay, let's go over. And usually, you know, customers, they tell you, I want all the features. Of course, we all know you can't have all the features. So this is this is how agile development got born, which is iterative development. So you build small pieces. You divide your bigger problem into smaller problems, and you build solutions for the small pieces, and you get constant and continuous feedback. So this represents the start of the project. So you talk to the business people, they prioritize things. How do you prioritize things? Like I told you, you actually go out to who you think is your market segment, and you seek representation of that market segment. And you talk to them, you get feedback on something, a prototype or a drawing or anything like that. And you start with your team, and you seek to actually build something that they can use and put it in their hands, and they give you feedback. And so in 6 months, you might reach a product that a lot of people want, as opposed to in 6 months, you reach a product that has a lot of problems, has a lot of fixes, and it's not what the customer really wants. Typically in agile development, this is a cycle that goes, you know, 2 to 4 weeks. Most important in product development, or the most used framework for agile, is called Scrum, where you have 2 to 3 week sprints. That means every 2 to 3 weeks you're building a shippable product increment. Means if you're a business owner, you're expecting every 2 to 3 weeks that you're going to cut a piece of software and you're going to put it on the App Store. Okay? Because the team is always taking requirements and features that you're constantly working on with customers from a stack and building them according to priority that you set as a business owner or the product owner. So eventually what you have here is something that you, through your good work, depends on that, have labeled as the features that are most needed by users. So when you put it out in the market, that's going to be what the people want. We can talk a little bit more about Agile when we do our activity. Because our activity is actually talking about this problem. We're going to make a Lebanese za'atar sandwich. But we're going to make it for, we're basically going to create instructions. I need each team to, we're going to have a cup of Lebanese and a jar of za'atar and some bread. And then you need to write down specific instructions in a specific way, in a constrained way, like developers do. Developers have a language, and when they have a language or they're using a specific technology, they are constrained by what that technology can do. So the whole idea of this exercise is to make you think like a developer, and to show you the importance of actually, literally, knowing that things that you don't mention or say will not be built just because somebody else has a crystal ball and they can read your head, it was your brain. But you need to be able to talk about it. So we're entering into the activity time, right? So what I need you to do is create instructions that only use the words that will be on the next slide, flashing on the screen. You have to have each instruction on a separate line. And I want you to make sure that each instruction ends with a semicolon. That tells the robot execute. That that instruction is complete. It's done. Okay. And we're gonna have every one of you is gonna have every team is gonna have 100 points. If you do nothing, you're gonna have 100 points. Okay. But we're gonna subtract my 5 points for anything that's messed up. Okay. And we're gonna make a little bit of a competition. Okay, so teams will be competing against each other for bronze, silver, and gold places. The bronze level will be good instructions that work, but might be messy with the process. Too many lines of instructions, maybe a little bit of waste, but eventually the robot can accomplish a sandwich. Silver is, we give the silver place to the team that actually creates instructions that are close to perfect with little or no waste. And gold will go to the team that has the perfect instructions, sandwich is built, but they're not going to use the word spread. And it's going to have the least lines of instruction. So if two teams have didn't use the word spread, the winning team would be the ones that have the least lines of instructions. We're going to do this in an agile fashion. So I want you to ask anything you want about the agile. The way we're going to do it is we're going to take about 15 minutes. We're going to have the first 5 minutes, second 5 minutes, and the third 5 minutes. Okay? Those are considered iterations in agile. So the first 5 minutes, you're going to take your first shot at creating perfect instructions for a robot. A robot doesn't understand anything except what you write. Okay? These are the words. These are the objects, so the things that the robot will be working with, and those are the actions. Okay? Every action must start with either left hand or right hand. So if I was the robot, the instructions would be left hand. Problem, define the problem, then do the planning, then actually do the coding. Okay? Somebody's jumping to the coding into development. You're pushing them to do that? Okay. Okay. Now none of you tested your instruction, and I saw a group that did something different. They started with the testing. Which is exactly what you're supposed to do. This is what we're talking about. Because if you start with the testing, you know exactly what you're supposed to do. And you're going to build exactly what you're supposed to build. So let's start another 5 minutes. Go.
Alright, ready, set, go.
Hello. Start on a clean page.
Hey guys!
Don't continue where you stopped. Leave that page, start a new page, and do another iteration. Okay? And this time, try to think differently. Try to reach testing. Try to reach testing.
Time starts, go!
1 or 2? You didn't look at that. Okay. How about you? More than before? We were in planning stage, so now we're in code. No. 13. We have 13 lines. Did you accomplish the sandwich? ولا have we done ولا لسه في اسمع احنا مش اكتر اقل. احنا اقل من بدي بس quickly. It was easier the second time to reach.
Hey everyone.
It was easier the second time. The second iteration was easier than the first one. Some common language between you. You started understanding each other. Maybe you approach the problem from a different angle. Okay? You have to start over again. Okay? What? You start over again, another 5 minutes. This is the last 5 minutes. Okay, I have to remind you, repeat X times X. For those of you who, I forgot to say that, X you can replace any number. Okay, you can use numbers freely. 1, 2, 3, 4, 5, 6, 100. You can use numbers anywhere you want, however you want. Okay, so start another 5 minutes, another iteration. You must, this is the final.
We should do it, right?
Yes, this is the final countdown. You must achieve a sandwich.
Hey everyone, be quiet. Everyone be quiet. Listen to what he's saying.
It's just one instruction.
Yes.
You can't write anything along with it. Okay. So if you want to do anything else with the hand, another instruction.
Another line.
We can use
If you put the sandwich, start over. Who thinks they have instructions to make sandwiches?
It depends what kind of sandwich you want.
Two pieces of bread or just one?
That would be an open face sandwich, it's a sandwich. Do you have a sandwich?
We have.
You ate the sandwich? Do you think you have a sandwich? Yes. I'm gonna try this route. Follow the instructions. Close the lebanon. Done? Right hand, pick up. Where's the dimension?
خلاص اعتبر
Pick up, plate, and lower. Where's the end?
هيا
You use the word. So, right hand is picking up the plate. Okay, so pick up plate and lower. Right hand, pick bread, lower onto plate. Right hand, pick up bread, lower onto plate. Okay. Left hand, pick labani. Left hand, pick up labani. From where exactly?
وين بدها خلص علق السيستم
Pick it up from here. Right hand, open lemon. Okay, I'm having difficulty. Repeat. If you said left hand, pick up bottom. Lemon. Right hand, open lemon. I don't understand what open lemon is.
جار اقول لك مش كاتب جار
You have to tell me the top lid.
The top lid.
Remove it. That will accomplish that. But now we still have 11 closed. We don't have a sandwich. Sorry.
Can you try ours?
Execution.
You missed something. But you have to remember this is a robot. Only understands those words. Nothing but those words. It has to somehow accomplish the sandwich using only those words. And The development you have to specify how many because somebody will have to be literate. Right, let's try this.
That's it, we lost.
Left hand, pick up 11 in top. Oh, left hand, pick up 11 in top, but you didn't say from where. Yallah. Right hand, unscrew 11 in top.
هذا الزعفر.
Right hand, put down 11 in. Put down public. Put down public. It's not screwing. How do you remove it? This one you unscrew. Pick up the right handle. Put 11 down. Anyways, you stop at the robot to unscrew something that's not unscrewed. You know why that happened? You didn't test. You tested, you didn't realize. You actually open this and you open this. Let's try it. Left hand. Hold that bottom. Excellent. Right hand. Oh, they even have the direction. Right hand. Left hand, hold Lebanon button. Left hand, hold Lebanon button. Right hand, remove, hold Lebanon. Right hand, put down. Left hand, pick up red slice. Right hand, pick up knife. Knife hands right.
So you can still do it, but you can still do it.
You can still spread it. That's not a problem.
Right hand, scoop lemon.
Oh, what you
Right hand. Turn left. Right hand, turn left. Right hand, press down. I'm supposed to bring them together. Press it like this.
We are supposing that missing a piece.
I'm supposed to bring them together.
What is that?
Right hand, press.
You're pressing down. You're pressing down.
Right hand,
You're right.
repeat 3 times. Okay. So we have this.
Not bad.
Not bad. One versus the other. We have something that we can eat, but we might be.
Left hand hold Lebanon top bottom. Right hand remove Lebanon top lid. Right hand pick up knife handle.
Were there
Right.
post revisions to this?
No, because we started on paper.
Yes.
Right hand scoop Lebanon top. Left hand pick up bread slice.
Left hand, pick up bread slice.
Bread slice. right hand, press down knife blade. Right hand, press down knife blade.
Press down.
Knife blade.
Knife blade.
Right hand, turn knife blade.
Turn.
No, we didn't specify that.
Turn 3 times.
Turn knife blade.
Exactly.
Right hand repeats 3 times.
Okay.
Right hand, put down knife handle.
Okay, that's good.
Left hand, put down bread slice.
Left hand, put down. Bread slice.
Left hand, hold bottom za'atar jar.
Okay.
Right hand, unscrew jar lid. Right hand, put down jar lid. Right hand, raise za'atar. Then-
Right hand, you said? Raise up.
Yes. And then we said right hand drops on that.
Let me just.
Did you say za'atar or za'atar jar?
Za'atar.
We were.
za'atar by
We ran out of time.
Okay, but you have to tilt the za'atar, and the za'atar will fall out. Tilt the za'atar.
Those words don't exist here.
Turn upside down, inside out, bottom left.
Turn bottom.
Did any za'atar get in the
Turn the bottom.
By coincidence? We have a Lebanese open face sandwich.
That was the goal, right?
We didn't want that.
We give you 5 points if we deduct any points.
Left hand, pick up Lebanese.
Yeah.
Left hand.
Pick up Lebanese tab.
From down. Down.
From down. From down. From down.
Push down.
From down.
Can see.
عنوان اذا بطلع على الممشي فاتك ممشي from down بس يلا خليها انا مش باين let's assume عشانكم
The gesture was busy.
left hand pick up Lebanese tab. Right hand remove Lebanese. Right hand remove Lebanese.
You had it. He cut the banana.
Okay.
Left hand put down Lebanese tab. Left hand pick up bread slice.
Left hand.
Right hand hold knife handle.
It's okay, my friend.
Right hand drop knife blade
In
in
Lebanese.
Lebanese tab. Right handle scoop knife blade in Lebanese tab.
Scoop. لا لسه خليك عنه يعني.
Right hand raise knife blade from Lebanese tab. Right hand lower knife blade to bread slice.
Where's the two?
Only two.
Those are words that I don't understand. Okay, ماشي كمل.
طيب
Lower.
right hand spread Lebanese on bread slice.
راح repeat.
Right hand repeat 6 times.
انت ليش تعمل repeat؟
Repeat what?
Which one?
The spreads? The scoop? Which one? Which one are we giving?
احنا بدنا سكوب بدنا نبت مش بدنا نحكي.
Yeah, spread. I spread. And repeat what?
Spreading.
Raise knife handle. لا هي كانت هون. Right hand raise knife handle from bread slice. Right hand knife
Count how many words you use.
Alright, we should. So you have
Two on. Okay, the objective was to build a Lebanese za'atar sandwich. Okay. أظن everybody here thinks it's a simple thing. It is a very simple thing, right? Okay. Giving instructions to a robot to build a Lebanese za'atar sandwich, it's no longer a simple thing because the robot comes with its constraints and limitations of what it understands, and it only understands these words. So when they say on, or off, with, they don't exist in my vocabulary as a robot. So I don't know what to do with them. So I'm gonna spit them out. Syntax error. Don't compile. Okay? Also, computers in general, software is dumb. It only does what you tell it to do. So it's very important to be literal in software development. It's very important to understand that the software developers themselves, they need you and they expect you to be literal. And they think like robots, not because they are robots. They are not robots outside of work, but they have learned or they've been programmed not to read between the lines anymore because it's all noise to them. So you need to specify what you really want. So don't get frustrated when developers say, what do you really mean? You have to tell them, what do you really mean? So try different words, try different ways, try different approaches. Working together, that's why we like pictures, we like mock-ups. In the second part of the sessions we talk about a lot of things that help you come closer to understand and be understood by developers and be understood by software builders. It's a very simple thing. It's a Lebanese za'atar sandwich. By the way, you can use the bread in Lebanese Gloria. But not one team accomplished the Lebanese za'atar sandwich perfectly. I think we came close here, and no, we didn't come close. Bottom, we stopped at the closed top or something. On we had we didn't have any Lebanese bread. On we had Lebanese za'atar, but dangerous.
No, you put it here.
It's not a sandwich.
You're not supposed to put it here.
I'm a robot. I don't understand what you're talking about. You didn't tell me to remove it over here. I was speaking.
حطينا put down knife بس ما حكينا انه
ما حطينا put.
from handle.
You have to remove it, separate it from here. Whatever you want. The point was to show you into iteration after iteration you got better at it. Okay. But Bardo, منكم iteration after iteration, you repeated the same mistakes. Because there was nobody to correct you, and usually in real life, who corrects you?
Customers.
Really, before the client is somebody very important.
Or the manager.
The tester. The tester. Okay. Usually the tester is actually complaining and telling you, this is not working. This is not working right. You need to do it this way. You need to repeat. So you have to appreciate what they're doing because they're your first safety net. So you don't have egg on your face when you go to phone it. So it's very important to have testers. Testers, I encourage every developer to take a course in quality assurance when they start as like junior developers. They must take the first level, foundation level software testing, whether they want a career in testing or not, because they have to understand testing and they have to understand that testers are important and they're not the garbage man. Okay? And this is very important in our culture. Okay? Because we have a tendency to think testing is not an important job. Although it's very critical to producing quality and making sure that I'm not speaking Arabic, ما تنفضحش مع العالم. Okay? Because somebody inside your organization is going to test the software and make sure it works correctly, give you feedback before you have your dirty laundry out in the public. The other thing you noticed, you got better. Okay, and you get better only if you used your tester, because your tester is going to debug things for you and then give you the feedback. This group did very well until Barash what happened, but they did very well at the beginning because they approached it correctly, like I was talking about. Everybody, I was looking at everybody, they were writing instructions. They were trying to think about writing instructions. Even worse, you know what was worse? Everybody was thinking about writing instructions without the word spread. Problem. That's extra. Nobody achieved a sandwich because you are going for much more than a sandwich. You were trying to go with for the gold medal.
Complication.
There's no gold medal. So you were complicating things before you solved the initial problem. You were actually introducing complications before solving the initial problems. Solve the initial problem first. Solve it. Make the sandwich. Now figure out how to remove the extra lines and not use the word spread. So your first time should have been planning, your second time should have been achieving the sandwich, and your third time should have been optimizing the instructions. Okay, but most people, I think everybody was going for optimization. Now what? Good. This group did very well. They did very well in that they started with testing. They started in and they told them to start making the sandwich. So he started picking up the hat and they started writing what he's doing to achieve the sandwich. So they wrote pseudocode, what we call pseudocode, which is human readable instructions. And then they tried to, how many IT people are in this group? 2, okay, that's one. And then they tried to take that pseudocode, or that human readable story of how to make a sandwich, and code it in this language, which is the correct approach, but somewhere along the line, you stop doing it right.
We know .NET, we don't know Java.
Look at it.
Nobody you stopped doing it right. You took the pseudocode, you started writing code, and you stopped testing it. That last piece that I was reading was not tested. If it was tested, it will work. So you should take part of the budgeted time for doing the job, to do the job and build the product, and you should take typically 30 to 35% of the time I reserve for testing, debugging, and refining. And that's if I have a team of experienced developers. It goes up if they're less experienced. It goes up to a percentage where 50% of the time we're building, 50% of the time we're testing. Okay? Because it produces the quality at the end, and you have to believe that. You have to believe in it. Okay? Because if you just build, you'll end up with something that's not usable. Okay? So I hope it was fun. You can have lemon and za'atar as much as you want.
Up to 3 sandwiches.
Any questions, any comments, any insights?
About the waterfall framework, is it obsolete now, or do you?
The waterfall.
In which case do you use it?
The waterfall methodology is not obsolete. These are methodologies. They are out there for you to use if you see they fit your conditions. Sure conditions. Where would I use or recommend using waterfall? If you know exactly what you're going to build and you have accomplished that and you're 100%, you know it.
It's not going to change.
And it's not going to change, which is extremely good. But for example, from my personal experience, we had a company that had a product. The product is being used by a wide customer base, and they wanted to make it on a newer technology, with newer interfaces. So they wanted to have a facelift for their product. It was 10 years old, 15 years old. Forgot what it was built on. They wanted us to build it for them on C#. Okay? So we know exactly where we're going. In this case, we took it, we defined it, we did the requirements, we went through a waterfall process. However, after experiencing Agile and Scrum, I took the waterfall methodology, and if you look at the here's the waterfall. If you look at the waterfall, in essence, Agile is not different than the waterfall. The only difference between Agile and the waterfall is that Agile is a bunch of waterfalls, little ones. So you're dividing things into smaller pieces, and you're doing the same process, but within a 2-week period. So if you lose any work, you lose 2 weeks worth.
Exactly.
Not more. Not 6 months worth, but only worth.
It's about risk.
Exactly, it's about risk management. So it's essentially the same. So what we did in this case is we know the product, so we know what we want to achieve, but we want to achieve it in new technology. So we know exactly the requirements. So this is defined very hard. We know how this is going to be exactly, because that's what we did before we committed.
But you had documentation also.
The program and what it does, the program is right in front of us. So every test case we can try, see what the old program does and exactly duplicate it. Okay? So we used waterfall, but the way we implemented it or executed it, we executed it in Agile, in Scrum. So we took the features, we took the requirements and the features here, and we split them up into logical units and put them all together. For example, this was a very complicated engineering tool that deals with sieves, gravel, measures the granularity of stones for engineering, for buildings, and for stones and gravel and sand and that kind of stuff. So it's very scientific, lots of mathematical formulas, lots of physics, it's very complicated. But that didn't bother us because we have the application. We can just translate what it does in new technology. So what we took the requirements and the features and we split them into logical units. And what we did actually 4-week iterations. It took us 18 months to finish. Okay. That product was built over 10 years. Okay, we took that, we refreshed it in 18 months, so in 4-week iterations. Each 4-week iterations there was a certain number of features that we had. And although we had this very well defined, and we could have went waterfall, we didn't do it agile, the way we did it, we would have ended up here in the turbulent area. Because, imagine, we have the application, we can use it, we know what it does, but there's still room for our interpretation to be different than the customers. Because we were looking at it, oh yeah, when you click this, you click that, it does this, okay, this is how we should build it. Then after 4 weeks we build those features, we do a demo. According to Agile, we demonstrate what we built to the customer. And they still find some problems with what we did. Oh no, this is not supposed to be that. Yeah, but the old one does that. Oh really? We didn't know that. They didn't know their own application did that. No, it's supposed to be like this. So we adjust and we... So even though we had something that is being used by a wide customer base, they, as a client, they appreciated the fact that we are even enhancing it, not just giving it a facelift, but we made it better by using the Agile process, by actually engaging them and doing these mini waterfalls and doing the testing. They give us the feedback. We put the new fixes in, and we continue.
Did you give this project the period of testing the same as other projects?
Basically, when I calculated the price for the project, yes, I calculated the waterfall. I did it for the testing. But my experience told me to run it in an agile fashion because I don't want to be here. I don't want the customer to be blind for months and then be in this turbulent area where we build what they don't want. Although it's clearly in Agile, the way we do the testing, we do it
Right after the iteration.
systematically. Not after the iteration, during the iteration. So, like when you were making the sandwich, you basically would write the instructions down, and you would be behind him reading the instructions and executing them. And go back a couple lines. There's something you messed up, something you missed, so you stuff it in. So you would have finished the 5 minutes with good instructions, although may have been not the full set of instructions, but you would have known that that set is perfect. And then you can build the set that comes after. And you don't have to go back to it, you already tested the tutorial. But that's the whole idea of Agile. Agile works for you and when you build startups, because startups, there's a lot of things that are unknown, there's a lot of things that you don't know. You don't know your market very well, you don't know what the customer wants. You have an idea. You're hypothesizing that if I build a water slide on the top of the highest mountain in Malta, that people will come and use it in the winter. Maybe they will, maybe they won't. You won't know unless you test it. But you have to test as you go, and that's what Agile encourages. You test as you go. So when you are done with a 4-week feature set, you may have, and the customers might need 10 features, right? And they told you, okay, we minimally need 10 features. Like I said, I need a sandwich. I don't care how many words you use. I don't care if you use spread or not. That comes later. When you're making 100 sandwiches, right? You want to be more efficient when you're making 100 sandwiches. But I want a sandwich at the end. So you shouldn't waste your time thinking about the 5 other features that you're not going to get to. Just think about the 4 features that you can deliver to the customer perfectly in the period of time that you have. So that's what Agile encourages. Scrum actually is a good way to manage products and product development because it makes you focus on what the customer wants now. Okay?